Hello students, welcome. Previously, Form 3, Topic 2, Lesson 18, we were dealing with direct titration, and we were dealing with the first aim of direct titration, which is determining the unknown concentration of the analyte. We have done example 1 and example 2. So today, Lesson 19, we are going to do example 3 and example 4. In example 3, we are told 25 centimeter cube of 0.1 molar sodium carbonate solution was required to completely neutralize 24.3 centimeter cube of hydrochloric acid. Full stop. We are told to calculate the concentration of hydrochloric acid in moles per liter. So, in other words, we are asked to calculate the molarity of hydrochloric acid. In previous lesson 18, we have done the steps of calculating direct titration. The first step was calculate the molarity of the standard solution if concentration is given in gram per liter. Second step was calculate the number of moles of the standard solution. So in our case, sodium carbonate is a standard solution because its concentration is given. Then hydrochloric acid is our analyte because we don't have the concentration, we have only the volume, and that's the analyte. So here we're not going to calculate the molarity because we have already been given the molarity of the standard solution. So our first step will only start with the number of moles of the standard solution, which is the sodium carbonate solution. So we start moles of sodium carbonate. Sodium carbonate solution. Moles is given by molarity times volume used over 1000. So our molarity is 0.1 times our volume used is 25 divided by 1000. So here we are going to get 0.0025 moles of sodium carbonate solution. So the next step of doing direct titration or calculating direct titration was you have to get the equation for the reaction between the standard solution and also the analyte. So the standard solution is sodium carbonate solution, then reacting with the hydrochloric acid, which is the analyte, aqueous. What we are going to get here will be sodium chloride solution. We are going to get water. We are going to get carbon dioxide. To balance the equation, we have to put 2 in hydrochloric acid and 2 in sodium chloride. Then the third step was we are supposed to calculate the number of moles of the analyte using the mole ratio. So sodium carbonate ratio hydrochloric acid. So here we have 1, which is Aden ratio. We have 2 in the side of hydrochloric acid. So if we have the number of moles of the sodium carbonate, we say 0.0025 moles. What will be the number of moles of the hydrochloric acid? We cross multiply. There, we are going to say 0.0025 times 2 divided by 1. So we are going to get here 0.005 moles of hydrochloric acid, which is our analyte. So the next step after that was we are supposed to calculate or use the moles of the analyte obtained in the above procedure to calculate the aim of the question, which is the concentration of hydrochloric acid in moles per liter, which means the molarity. So molarity is equal to moles times 1000 over volume used. So our moles of hydrochloric acid is 0.005 multiplied by 1000, which is in the formula, divided by volume used. So the volume of the hydrochloric acid is given 24.3. So 24.3. So here we are going to get 0.20576 moles per liter. That will be the concentration of hydrochloric acid in moles per liter. Or you can say this is just the same as 0.02576 M capital letter. That's just molarity. Okay, part 2 of the question, we are told grams per liter. Grams per liter, initially we were having a formula of calculating molarity, we said molarity is equal to concentration in gram per liter over the RFM. So if you are told calculate the concentration will be equal to molarity times RFM. Because if you want to get our subject formula as concentration in gram per liter, we will just multiply here by RFM and we multiply here by RFM. So RFM will go with RFM. So that means concentration in gram per liter will be equal to molarity times RFM. So there, if it's like that, we have to get the RFM. RFM of sodium carbonate. RFM of hydrochloric acid. RFM of hydrochloric acid. Hydrogen is having a relative atomic mass of 1, chlorine 35.5. 35.5. If you add, we get that 6.5 as the RFM of hydrochloric acid. So we said concentration in gram per liter will be equal to molarity times RFM. Molarity times RFM. So the molarity we have gotten there, it was 0.20576 multiplied by the RFM of hydrochloric acid, which is at 6.5. This will be equal to 7.51 gram per liter will be the unit. So that will be our answer for part B of question 3. So we go next question 4. Question 4, we are told 25 centimeter cube of sodium hydroxide solution containing 4 gram of the alkali in 400 centimeter cube required 27 centimeter cube of dilute nitric 5 acid for complete neutralization. Calculate the concentration in moles per liter of part A of the question, the sodium hydroxide solution. So here, the information that I have on sodium hydroxide is 25 centimeter cube of sodium hydroxide solution containing 4 gram of the alkali in 400 centimeter cube. Required, and this other side is for nitric 5 acid. So in this question, the standard solution will be sodium hydroxide because we can have its concentration here. The concentration is 4 gram of the alkali. That means 4 gram of sodium hydroxide was dissolved in 400 centimeter cube. So nitric 5 acid will be the analyte because we have the volume. We don't have the concentration. So if we want to get the concentration of sodium hydroxide in moles per liter, we can have 4 gram. We said 4 gram of sodium hydroxide has been dissolved in 400 centimeter cube of distilled water. So we say, what about 1,000? What about 1,000 centimeter cube? That one will give us now the concentration of sodium hydroxide in gram per liter. So to correspond to we are going to get 4 times 1,000 divided by 400. So here I'm going to get 10 gram per liter. So remember, molarity or concentration in moles per liter will be equal to concentration in gram per liter over the RFM. So I have to get RFM of the sodium hydroxide. And air with sodium is 23, plus 16 for oxygen, plus 1 for hydrogen. This will give me 40. So next, I have to use the formula, and I say molarity will be equal to concentration in gram per liter, which I've gotten 10, divided by the RFM, which I've gotten 40. This will be equal to 0.25 mole. That will be the answer. Learners, it's not must you to use this formula. Instead, you can use the other formula of calculating molarity by using molarity equal to moles times 1,000 over volume used. So you start your working on getting the number of moles by using mass of the sodium hydroxide divided by the RFM, which is 40. Then that's your number of moles. So molarity will be equal to moles times 1,000 divided by volume used. So your volume used will be 400. So you will still get 0.25 moles. So we go part B of the question, the nitric 5 acid. So we're supposed to calculate the concentration of nitric 5 acid in moles per liter. So if they want the concentration of nitric 5 acid, I have to first of all get the number of moles of the sodium hydroxide. Remember, I've gotten the molarity of the sodium hydroxide. I've been given the volume of sodium hydroxide, so I can get the moles of that standard solution. So we said moles is given by molarity times volume used over 1000. So my molarity of sodium hydroxide is, my moles of sodium hydroxide is 0.25. My molarity is 0.25 multiplied by 25, which is the volume of that sodium hydroxide, divided by 1000. So here I'm going to get 0.00625 moles of sodium hydroxide. So next, I can get the number of moles of the nitric 5 acid, which is the analyte, by writing the balanced chemical equation between the standard solution and the analyte. So we are going to have sodium hydroxide aqueous plus nitric 5 acid aqueous. I'm going to get sodium nitrate aqueous plus water, which is liquid. So to get now the mole ratio between the standard solution, which is sodium hydroxide, ratio the analyte, which is the nitric 5 acid, it is 1:1. Then we have gotten previously the number of moles of the sodium hydroxide. So it was 0.00625. So we ask ourselves, what is the number of moles of the nitric 5 acid? So here it will be 0.00625 times 1 divided by 1, which is 0.00625 moles of nitric 5 acid. So if you have the number of moles of the analyte, you can get the molarity by using the formula moles times 1000 over volume used. So we are going to say molarity of nitric 5 acid will be equal to moles of nitric 5 acid multiplied by 1000 and divided by the volume used, or the volume of nitric 5 acid. This will be equal to, the number of moles will be 0.00625 times 1000, which is in the formula, divided by volume used. So what is the volume of the nitric 5 acid? 27 centimeter cube of dilute nitric 5 acid. So that means the volume will be 27. So here we are going to get 0.23148 mole. Because I'm told, calculate the concentration of nitric 5 acid in moles per liter, which means molarity. That is the end of our video.